Today's lesson is 8-5, day 2. Our objectives today are to factor perfect square trinomials. These are perfect squares. You do not have to write these down because they're on the handout that we gave you. So perfect squares would be 1, 4, 9, 16, 25, 36. What makes them perfect squares is the fact that you can square a number and get that number. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So these are all of the perfect squares that we're going to be looking at. Also, you can also take the square root of that number and get a nice pretty number and not a decimal. A trinomial is a perfect square if the first and last terms are perfect squares, and you do not have to write any of this down either because your rules are also written on the handout that we gave you. The middle term is 2 times 1 factor from the first term and 1 factor from the last term. The perfect square trinomial a squared plus 2ab plus b squared factors into a plus b times a plus b or a plus b squared. Or if I have a squared minus 2ab plus b squared, then I have a minus b and a minus b. We know that there's either a plus sign in both or a minus sign in both, and we look at this sign right here, this first sign, to tell us whether it's going to be a plus sign or a minus sign. This end term right here has to be a plus sign in order for that to work. Here's an example of this. Again, you do not have to write this example down. We just want to kind of let you see how this is going to work. Your first term has to be a perfect square, and 9x squared is a perfect square, so is 4. So I can split 9x squared down into 3x and 3x, and 4 down into 2 and 2. Last time there had to be a minus sign in the middle in order for the perfect square binomials to work. When it's a trinomial, meaning 3 terms, our middle term has to work in order for this kind of shortcut to work. We always have to say 2 times one of these times one of those, and when I do that here, 2 times 3x is 6x, and then times 2 is 12x. So we have to make sure that when we multiply these out, we get that middle term. Alright, here's number 1. Go ahead and write that down. We have x squared plus 12x plus 36. So again, we have to check to make sure that the first term and the last term are perfect squares. And we know that x squared is a perfect square because it's x times x. We can check our sheet for our perfect squares to make sure that 36 is on there. Okay. And 36 is a perfect square because it's 6 times 6, or 6 squared. So the first term and the last term are both perfect squares, so we're good there. So we're going to split those up and say x times x. And instead of 36, we're going to say 6 times 6. Now again, when it's a trinomial, in order for this rule or this shortcut to work, we have to check this middle term right here, this 12x. And to do that, it's always a 2 times one of the things from over here, so times x, times one of the things from over here, so times 6. So we're going to make sure that works. 2 times x is 2x, times 6 is 12, so our 12 worked. So this rule or shortcut can work. We need our 2 sets of parentheses. Our x's here and here are going to be our first here and our first here. And then our 6's are going to go here and here. And then to figure out whether it's plus, plus, or minus, minus, I'm going to look at this first sign right here. If this first sign is plus, it's plus, plus. If that sign was a minus, it would be minus, minus. And a different way of writing this, and the way that you'll see it on EOC, is going to be x plus 6 squared. Take a minute and make sure you have that written down. Alright, so again, make sure you have this written down. We're not going to check these because hopefully at this point you know how to check. Alright, go ahead and write down number 2. Number 2 is y squared minus 16y plus 64. Again, in order to use this shortcut when we have a trinomial, we have to look and say, okay, is the y squared a perfect square? Then we have to check our paper to make sure that 64 is a perfect square. If I check my paper, 64 is on there. It's a perfect square. It's 8 times 8, or 8 squared. So it is a perfect square. So let's go ahead and split these up. Y squared is going to be y times y. 64 is going to be 8 times 8. And again, we have to check to make sure that the middle term works. And we'll talk about in a couple more examples what to do if the middle term doesn't work. But right here, we're going to check the middle term. It's going to be 2 times, again, 1 from over here, So we're going to bring over that y times one of these. So 2 times y is 2y. 2y times 8 is 16y. So we get our 16. Doesn't matter that it's a negative 16. We just are looking for that 16 number. So since our middle term works, we can kind of use this shortcut or this rule here. So we're going to say y and y, and then our 8 and 8. And then we need to determine whether it's going to be plus, plus, or minus, minus. So again, we look at this sign right here, this very first sign, and it's a negative or a minus. So it's going to be y minus 8 and y minus 8. Or we write it as y minus 8 squared. Make sure you have all of that work written before you move on. And again, we're not going to check this one because hopefully you can check it yourself if you would like to do that. Alright, go ahead and write down number 3. Number 3, we have 4n squared plus 20n plus 25. Again, we need to make sure that we've got perfect squares. Our first one needs to be a perfect square and our last one needs to be a perfect square. So I need to check for 4 and 25 on my perfect square sheet. 4 is on there and it's made up of 2 and 2. And 25 is on there because it's 5 times 5, or 5 squared. So they are both perfect squares, so is the n squared. So I'm going to split 4n squared up into 2n and 2n. Now I'm going to split 25 up into 5 times 5. And again, I have to check that middle term to make sure that it works. And again, that's always 2 times one of these, so 2n times one of these. Come over here, so I'm going to say 2 times 2n is 4n. 4n times 5 is 20n. So that gives me the 20 that I need, so it works out. So I can use the rule. So we're going to say 2n and 2n here. 5 and 5. And then again, I'm going to look at this sign right here. It's a plus sign, so it's going to be plus, plus. And my other way of writing that is 2n plus 5 squared. And again, I would like them written as 2n plus 5 squared. Take a minute, make sure you have all of that written before you move on.
I go ahead and get down number 4. It's x to the 4th minus 6x squared plus 9. Now we're going to break down our perfect squares. X to the 4th is the same thing as x squared times x squared. And then 9 is a perfect square of 3 and 3. So now my middle term is going to be 2 times a factor from the first term and a factor from the last term, which gives me my x squared and my 3. And now I'm going to break it down into my parentheses. So I have x squared. Well, I'm sorry, first I need to check this to make sure that this is going to equal 6x squared. So 2 times x squared times 3 is going to be 6x squared. So that does check, so it does work. So now I can bring it down and put it in my parentheses. I'm going to bring down this term here, my x squared, bring down my 3, sorry, my x squared, my 3, and my 3. And because this sign right here is a minus, I'm going to put a minus there and a minus there. I could also write this as x squared minus 3 squared. And again, that's how you're going to see it on the EOC. Make sure that you have all of that down before you move on. All right, go ahead and write down number 5. It's 9m squared plus 60mn plus 100n squared. Now we have to look at our perfect squares here and realize that we know that m squared is a perfect square, but also the number in front of the m has to be a perfect square, and 9 is a perfect square. So when I break this down, 9 is 3 times 3, so I'm going to break it down as 3 and 3, and m squared is m times m. So it's 3m times 3m. Over here I have 100, and if I look at my perfect squares chart, it shows me that 100 is a product of 10 times 10, and then again I know that n squared is a product of n times n, so that's 10n times 10n. So now I have to just check and make sure real quick that my 60mn is going to come if I multiply 2 times one of my first terms times one of my last terms. And I can see that 2 times 3 is going to give me 6m, and then 6m times 10n is going to give me 60mn. So that does check out. This will work. So now I'm going to bring this down and put it in my parentheses. I'm going to bring down my 3m, my 3m, my 10n, my 10n, and I'm going to look up here and see what sign. I have a plus sign here, so I'm going to put a plus sign in each set of parentheses. Again, it could also be written as 3m plus 10n squared. Make sure that you have all of that down before you move on. All right, go ahead and get down number 6. It's 9a to the 6th minus 30a to the 3rd plus 25. So don't freak out because our a has an exponent of 6 here. As long as our exponent is an even number, we can make it into a perfect square. As long as our exponent has an even number, it's a perfect square. So I know that 9 is a perfect square of 3 and 3. So 3 times 3 is going to give me 9. And I know that when I multiply and I have the like base number, all I do is add my exponents. So I'm going to add a to the 3rd times a to the 3rd would give me a to the 6th. So that's how that breaks down. Over here, I know that 25 is a perfect square of 5 and 5. So now all I have to do is just check my middle term and see if this is going to work out. So I have 2 times 3 a to the 3rd times 5. One term from here, one term from here. 2 times 3 is going to give me 6a to the 3rd times 5 is going to give me 30a to the 3rd. So that checks. So I'm ready to move on. I'm going to bring it down and put it in my parentheses. It's going to be 3a to the 3rd, 3a to the 3rd, 5 and 5. I'm going to draw my parentheses. And then I'm going to look at my sign here. It's negative. So it's going to be a minus in both sets. And it could also be written as 3a to the 3rd minus 5 squared. So make sure that you have that down before you move on. All right, go ahead and get down number 9. Sorry, that's not number 9. It's number 7. Get down number 7. It's the ugliest 7 in the world. X squared plus 10x, I tried, plus 7. I'm sorry, plus 16. Geez. X squared plus 10x plus 16. So the thing is that this may seem a whole lot simpler than what we've been doing, and in a lot of ways it is, but sometimes a problem can look like it's a perfect square trinomial when it's actually not, and that's why in every single one of the ones that we've done so far, we've made you check that middle term. So here we have x squared, which we know is a perfect square. It's x times x. And here we have 16, which we know is a perfect square, 4 times 4. Now, by our rule here, to get our middle term, we have to multiply by 2, and then one term from the first set and one term from the second set. So 2 times x is 2x times 4 gives me 8x, not 10x. So that doesn't work. That gave me 8x, not 10x, and I had to have 10x there in order to be able to do it the way that we've been doing it. So that didn't work. So that means, not that I can't factor this trinomial, but it just means this way is not going to work. So what I have to do is I have to go back to the old way, and I'm going to multiply my first term times my last term, which is going to give me 16, and then I'm going to come over here, and I'm going to list my factors of 16. All right, so I've listed my factors of 16 here. 1 and 16, 2 and 8, and 4 and 4. And you need to do the same as well on your paper. And we're going to figure out which two factors we could add up to get this 10. So I'm going to draw a little box around my 2 and 8 here because that's what I'm going to use. I'm going to rewrite the problem just so it's a little bit neater. It's x squared plus 10x plus 16. And then I'm going to break up my 10x to 2x and 8x. I'm going to bring down my 16 and bring down my x squared. Now I'm going to factor my first group. Just like I've been doing all along, I'm going to pull out an x here, and it's going to give me x plus 2. Here I'm going to factor out an 8, and that's going to give me x plus 2. So in my parentheses, that gives me x plus 2 and x plus 8. So that would be my final answer on this one. It is not a perfect square trinomial, but that doesn't mean that it can't be factored. It just means that it can't be factored using the shortcut way that we've shown you today. Make sure that you have all of that down before you move on. All right, go ahead and get down number 8. It's y squared minus 9y minus 36. I'm just going to go ahead and explain something to you real quick here. If you've noticed, all along, all of our problems have either had a minus and then a plus, or a plus and a plus, okay? This minus minus right here means that it is not a perfect square trinomial. The minus minus, this minus sign right here, tells me this is not a perfect square trinomial. It cannot be factored using the shortcut method. It has to be factored using the old method. I am not going to show you, not a perfect square trinomial, because of this sign right here, okay? And I just want you to draw attention to that. I'm not going to make you factor this the old way because you've been doing it for like 3 days now, 4 days. You should know how to do it by now. But we just want you to be aware if the second sign is a minus sign, it's not a perfect square trinomial and it can't be factored using the shortcut method. So just make sure that you have that written down before you stop the video. And that is your last example for the day. Thank you for watching.